I'm John Sterman. I'm the J.W. Forrester Professor of Management at the MIT Sloan School, and I direct the System Dynamics group there and co-direct our sustainability initiative. Climate change is a classic systems problem, and we've been developing a set of models for policymakers and businesses on that topic. Our research isn't basic research in climatology. MIT has phenomenal people doing that. Our research is about how you get the results of that scientific research out there to the policymakers and to business leaders and the public and educators in a way that they can actually understand. If you look at the public opinion surveys, it's very clear that while the scientific case that climate change is happening now is caused largely by human activity, poses serious risks to human welfare, that research is strong and getting stronger, but public understanding of the issues and public desire for action is stagnant or even perhaps falling. So the real bottleneck to action on this issue, whatever your political point of view, to avoid those risks for ourselves and our children and our grandchildren, the real bottleneck on those issues is education and communication. So we've done a variety of laboratory experiments to identify exactly what are the areas that people find difficult, and we've developed a set of policy-oriented models which are in use now by the United States government, for example, in China, and by the UN, to help the policymakers understand this. The models that we've developed are different than the large climate models that are used in the primary research. Those models take weeks or even months to do a single simulation. They're absolutely necessary. We can't make progress on the science without them. But if you're a policymaker faced with a new proposal on the eve of negotiations, you've got to evaluate that proposal right now. You can't wait. And so our model runs on an ordinary laptop in less than a second. It behaves exactly the same way as the large models. We've calibrated them very carefully so that it behaves the same way as the large models. And it gives, for the first time, policymakers the ability to try their own scenarios, to put in the proposals that are being presented to them by other nations, other parties, and see what the likely impacts are on the future climate. How much warming is there likely to be? What might happen to the pH of the ocean, for example, or sea level rise, just to pick a couple of impacts. That ability is enormously important. There's no learning without feedback. You can't learn from experience unless you know what happens as a consequence of your decisions. In the world of the climate, you can't do that by waiting to see what's actually going to happen, because by the time we wait and see, if it turns out climate change is actually going to be harmful to human welfare, it'll be too late to do anything about it. So we have to use simulation models. If those models are going to be effective, they not only have to be rigorously grounded in the science, as our models are, but they have to be transparent, accessible, they have to run quickly and give people that immediate feedback on any experiment that they may want to run. So those models are now being used, our models being used by the negotiators for the United States in the UNFCCC process. These folks are out of the U.S. State Department. We have a version of the model that's running in China, is being used by policymakers there, the national level and at the provincial level. It's being used by the United Nations to assess the impact of the pledges that have been made under the Copenhagen and Cancun process. And we're getting it out there for business leaders and educators. So a major issue with climate change policy is that the developing nations, China, which is now the world's largest emitter, India, whose emissions are growing rapidly, Indonesia, Mexico, Brazil, other countries that are now beginning to enjoy some of the benefits of economic development, they worry that a climate change policy would mean an end to their economic development. I think that's a big myth. Limiting greenhouse gas emissions does not mean limiting economic development. It does not mean an end to poverty reduction. It does not mean an end to improving food security for the billion people now who don't have it. Those two activities are separate. We don't really want energy use per se. What we want are the services that energy affords. What we want, in the famous words of Amory Lovins, is cold beer and hot showers. What we really want, of course, is a good, clean, decent, safe, warm place to live, access to the services that we want and need, education, access to good jobs, the ability to get out and enjoy nature. And that can be done with renewable energy, low carbon energy. So it's a myth to believe that we can't reduce our greenhouse gas emissions and preserve the planet for our children without cutting off economic development. Now, having said that, the United States and the other developed countries have been the largest cumulative emitters of greenhouse gases. China's now the largest emitter, and its emissions are growing very rapidly. But historically, most of the greenhouse gases that are in the atmosphere came from the developed countries. And the United States is still the second largest emitter. So it's absolutely imperative that we lower our emissions here. And there's good evidence that we can do that and do it cost effectively and do it in a way that creates jobs here. And that's really part of the research challenge, not only developing the new technologies to do that, low carbon energy, renewable, solar and wind, but to develop the economic policies, the attitude changes, the social changes that will enable those technologies to be deployed quickly enough. What we know from the science is there's no time to wait.